Okay, we're going to do lesson 3.6, which I hope is a little bit of a review on the definitions of sets of numbers, and then we're going to look a little bit more about inequalities. So if you remember from the beginning of chapter 1, we talked about natural numbers. And I don't know if you remember from that class or not, but these are also called counting numbers. So when somebody says count something, what do we start with? We start with 1, don't we? So these are numbers like 1, 2, 3, and they are an infinite set of numbers. They go on and on and on. So the pattern continues forever. The second set of numbers I want us to think about are whole numbers. These numbers are slightly different from counting numbers. They begin with 0, 1, 2, 3, dot, dot, dot. And in fact, they also include the additive inverse, or the opposite of natural numbers, which are the negative numbers. So they can be it can also be written this way. Dot, dot, dot. It shows infinity. -3, -2, -1, 0, 1, 2, and 3. Dot, dot, dot. Okay? So it goes both ways, infinitely negative and positive. All right, so the section that we're going to work on now talks a little bit about inequalities, and we're not going to, I did not assign the textbook questions that I had on the syllabus. We will probably go over these a little bit more in class, but if you could look at example number page 118, number 3, it gives us an example that looks like this. It says, for the inequality 3x is less than -6, and then it gives me a semicolon, and it gives me several values: -5, -3, -1, 0, or 2. Okay, so it's asking me these 5 values, or these 5 terms. If I were to use these terms for x, does it make this statement, 3x is less than -6, does that make that true or not true? So what do we do to solve these? It's really not that hard. We just take one at a time. We're going to take each term and we're going to substitute it for x. So for the first one, I'm going to have 3 times -5 is less than -6, and we're going to find out if this is true. -15 is less than -6. Is that true or false? That is true. Or you could say yes. All right, now we're going to take, the second thing we're going to do is take the -3, and we're going to put it in for x as well. We're going to do -3 times 3 is less than -6. And I have -9 is less than -6. Is this true? Yes, it is. -9 is less than -6. It's true. All right, now I'm going to put in my -1. So I have 3 times -1 is less than -6. -3 is less than -6. Is that true or false? On our number line, if we have 0 and I have a -3, which would be right here, is that less than a -6 way down here? It is not. So this answer is false. All right, now I'm going to use my 0. 3 times 0 is less than -6. Well, 0 is not less than -6. So this one is also false. 3, here's my 0. negative 6 is less than my 0 up here. So that is a false statement. The last thing I'm going to do is use my 2, and I'm going to say 3 times 2 is less than negative 6. And this also is going to be false because 6 is not less than negative 6. On my number line, 1, 2, 3, 4, 5, 6. This 6 is not less than negative 6. So my answer is false. The question asks us which numbers are members of the solution set. A solution set consists of the integers that make the inequality true. Okay, so a solution set are integers that make the inequality true. So the two numbers that are part of this solution set that make this true are -5 and -3. So if it asks me what my solution set is, I'm going to tell them that my solution set equals -5 and -3. All right, let's take a look at another example. I'm going to turn the page, and I'm going to go to section number 21 through 32. This is a section we're going to look at to help us answer this. So let's take a look at 23. This one says negative 9x is not equal to 72. And then it gives me several numbers beside it. -8, 0, 8, 16 to try. And now it wants me to give them the numbers that are a part of the solution set. So my answer is going to be in this range right here, these four terms. So let's just start plugging those in. First one I'm going to take is -8. I'm going to say -9 times -8 is not equal to 72. Well, 72 is not equal to 72. That's false, isn't it? That is false. -72 is equal to 72. So that is wrong. So I know that -8 is not going to be in my solution set. Let's take 0. Do 0. -9 times 0 is not equal to 72. Well, 0 is not equal to 72. That's true. 0 is not equal to 72. So I know that in this solution set, I am going to be including 0. Let's look at 8. Let's do our next one. Let's take the 8 and put it into our equality. -9 times 8 is not equal to 72. If I do the math on this side, it's -72 is not equal to 72. And that is true. Those are opposites, right? They are additive inverses of one another. So that makes me say that 8 is going to be in my solution set because that answer is true. The last one I have is going to be 16. -9 times 16 is not equal to 72. And that is also going to be a true statement because this is a negative number. And that's going to give me 144. Is not equal to 72. And that is true as well. So -16, or I'm not sorry, not -16, but 16 is going to be in my solution set. So when it says, what is your solution set? What numbers are a part of your solution set? I'm going to say 0, I'm going to say 8, and I'm going to say 16. Those three numbers make my statement -9x is not equal to 72, true. Okay. This is the concept I was hoping you guys would be able to cover at the end of class, but we had so much work on the simplifying. I didn't want to really get too much into this now. Let's look at one more example, and then I'm going to turn to the next section. Let's look at number 29. I'm going to square this off just a little bit so we can see. Y plus a negative 4 is less than or equal to, pay attention to our signs here, a negative 8. And the numbers it wants me to try are negative 4, 0, 4, and 8. All right, so I'm going to take a color per number, and we're just going to plug it in. I've got negative 4 plus a negative 4 is less than or equal to negative 8. On this side, I've got a negative 8, and I've got a less than or equal to negative 8. So this answer is true. Negative 8 is less than or equal to, remember this sign means equal to as well, negative 8. So I know in my solution set, I'm going to have to include negative 4. All right, now let's take my 0. See what that does. 0 plus a negative 4 is less than or equal to negative 8. All right, well, I've got a negative 4 on this side is less than or equal to negative 8. So on my number line, remember, if you want to be a visual learner, I have a negative 4 here. I've got a negative 8 here. Is negative 4 less than negative 8? No, it is greater than. So this cannot be true. This answer is false. So 0, it will not be included in my solution set. Let's look at 4. 4 plus a negative 4 is less than or equal to negative 8. Well, actually, we know, based on the inverse property, that a positive and a negative, and the positive and negative integer, the same one, equals 0. So 0 is less than or equal to negative 8. And we're looking at our 0 up here. 0 is greater than negative 8, so this is going to be false. 4 will not be included. Now, you might be able to say, well, if 4 is not included, I know 8 won't be included, and I would have to agree with you, but let's go ahead and do the math anyway, just to check it. So if I have an 8 plus a negative 4 equals negative 8, I'm sorry, it's less than or equal to negative 8, I'm going to have 4 is less than or equal to negative 8. And my 4 would be on this side, 4 is greater than negative 8, so this is going to be false as well. So the solution set for this inequality, out of the 4 numbers that we were given, the only answer is negative 4. We'll talk a little bit more about this in class. We're not going to do any homework on it now, but I just wanted to kind of go over it. The next section we're going to work on is going to be solving linear inequations and looking at how we graph those. So if you have questions on that, you'll want to see the next video.